So this next section we're going to talk about our external dependencies. So we've seen how we can have two different projects or two different components inside Gradle have dependencies on each other. But the next thing up is, like, if you look at the JVM domain, we can say I want to depend on this library that somebody else has built, someone's published into Maven Central. I want to go download it and compile against it. So that's like the next big thing that we need to add for the native space. So it has to be able to handle resolving binary variants of differing build types, which is debug release or optimized or whatever else. The whole different flavors that you can have for your library. So the free version of the application should only link with the free versions of the libraries or something. We have different metadata formats. So talked about package config is a good example of it has dependency information inside of it, but it also has link flags and compiler flag and all sorts of other things inside of it. So right now the current support we have is basically the local project dependency. So in a multi-project build, you can depend on other components in the multi-project build, and you can also depend on something we call prebuilt libraries. So prebuilt libraries are libraries and header files that have been created in some other way or have been found in some other way. So you've got them checked into your version control system, or you have them in a well-known path that everybody has access to, or you have some sort of custom thing that you added to download a zip file and extract it during the build. And basically, prebuilt libraries is a way for you to say, Gradle, there's a library with this name, with these headers, with these static libraries or shared object libraries, and let me link against it as if it were like a local project. So this is what it's going to look like. So here's an example of a prebuilt library that consists of just headers, or a prebuilt library that consists of a shared library and a set of headers. And so it looks similar to what you'll see with the components, where we say we have sources in a certain place. So here we say our headers are in a certain place, and we configure the binaries like we would configure binaries for a component. Only here, instead of saying these are your compile flags and these are your whatever, here we're just saying here is where the file is for this particular thing. So here we're saying my Windows library, the shared library file is in this path, and that's just where it is for all. When you go to link against it, that's where it's going to find the library. So we want to have a lot of improvements in this area. Adam talked about a little bit this morning. We want to bake in all of that kind of metadata into things that we publish, but we also want the prebuilt libraries to kind of work a little bit easier, and having maybe like a conventional location. If you lay out your prebuilt libraries in this conventional location or conventional layout, then all you have to say is I have a prebuilt library, it's called this, and Gradle knows how to find all that. Other types of variants that we have to start worrying about are ABI and runtime parts of the platform. Right now the platforms are kind of limited to Windows, 32-bit, 64-bit, that kind of level. All right, so next thing we're going to go to is another lab. So this is a Prebuilt Libraries lab. It's 03. Let's see. Still see that? It's kind of light, but so with this, you're given some sources to some pre-built libraries. One is, I think, Boost, and the other is CUnit. And what we're going to do is define a couple of pre-built libraries and link them in with our two executables that we're building here. So we'll give you 15 minutes. Please see me or Gary if you have any questions. Start. That's what I was doing while I was sitting here. Yeah. this from watching Mark Murphy.
Oh, really?
Like he was using that. I was like, that's clever.
What is it? What tab?
Yeah, it's timer tab.
Oh, timer tab.
Yeah. Timer dash tab. Yeah, when I'm not full screen, you also can see the tab name changes with the timestamp in it, or the time countdown. And I think if you click on it, it like zooms in. Yeah. So really put the pressure on.
Nice. I'm gonna use that.
Just Mark going again.
Good.
I have this annoying timeout set on my laptop. There we go.
Caffeinate.
Ah, yes.
I always forget to use it, but
I think it's funny. I just found it like last week.
really,
And I was like downloading something and it kept going to sleep, and I was like, there has to be something.
I think dash D will keep the display. Tell me when.
Oh, I think it does everything. So. Yeah, is that in seconds or minutes? What I just said it to. It's in seconds. So that's 2 minutes. That's not what I want. It's a gigantic number. There we go. Don't do
Well, I
it.
think if you don't even give it time, you can just say
I'll just still go. Just
you
go.
can caffeinate. Like I always do dash D, which keeps the display from locking. Just do caffeinate dash D, and it'll just sit there until you cancel.
I'm gonna cheat.
A couple of years from now, someone's gonna write a cookbook.
I'm worried about that day when someone says, "Hey, we need a Gradle." What's the name of Ben's? Gradle, is it Gradle in action
Gradle
or?
in action,
Yeah, Gradle in action, like native. I think time went by faster for you. Seems like slowed down for me.
I'm lost by where it says contains the static library appropriate for
Right.
sorry.
Okay, so go back to that Prebuilt libraries example in the slides here. Yeah, that's what I'm.
Sorry, I have the other
Yeah, it's gonna be past.
forward.
Yep. The section that we just covered. Yeah, right there. Okay. So, actually the example is not over here for static libraries.
Example for.
In the slide, it only shows shared libraries.
Oh,
Yeah, but
it's a challenge.
yeah, you can look at it in the DSL. That's one way to. Yeah. Yeah, you can probably extract it and guess, how to do it, but.
Can we go show that in the up here? About the static library?
Yeah.
Yeah.
Want to or whatever they want.
It's a couple more minutes. Anyone else having trouble with the same thing? I can try to. DSL guide. static, I said. Yeah. Yeah, so the example in the slides uses, I have a Windows library, and it's a shared library binary. That's the type of binary that we're configuring, and then we're setting the shared library file to this path to some DLL. Just like you can look for types of shared library binary, you can also look for static library binary. And when you do that, there's different fields that you set. And if you look on the DSL guide, you can go in here and I look at Prebuilt static library binary, and I can see that there's a static library file that you can set that will be the path to the actual library file. Okay, you want me to start going over the answer? Talking about it? Okay. All right, so what it's asking us to do is define two pre-built libraries. One's going to be called Boost, and one's going to be called CUnit. I'm going to cheat and steal a big chunk of code from the slide. So I'll say this is going to be my Boost, and its path is going to be down this path for the headers. Okay. Yes. Yes. Yeah. So right now, I guess that's the only type of repositories we have in the model space is this pre-built libraries repository. So it's basically just a container for pre-built libraries. So we're not specifying any kind of type. So it's some sort of domain object container. Okay. So we have a Boost library, path to its headers. We also need to define a CUnit library, pre-built library, and its path to, does it say what it is? No, I have to figure it out. Its path is going to be libcunit something. CUnit. Oh, crap. That would have been very, very bad. libcunit 21-2. And here, we instead of the CUnit is actually a static library, so we'll be configuring a static library binary, and we'll be setting the path to the file to whatever OS you're on. You'll have to pick the right one. So 21 OS X. Oh, this is the annoying thing about Sublime. It doesn't actually show me the contents of that directory. Switch. Yeah. There we go. Find libs, and it's called libcunit.a. Okay, so your path might be different if you're on a different OS, but so here's my CUnit Prebuilt library. Here's where its headers are, and here's the library that we're going to use for linking. So we've got these two Prebuilt libraries, and we want to add them to our two components, or two executables that we're building. So we're going to add one to Booster. So sources, CPP. I guess I can do it short way. I'll do it the long way this time. Boost. All right, so for the Booster is a C++ executable. So we have a dependency on Boost, and it's an API only dependency because it doesn't have any kind of library or anything to go with it. The unit tester is actually a C executable. And so we want to link against CUnit. We want it to be static. Okay. If we go and try to build this, or let's look at the task first. Make sure I didn't type anything wrong. So we can see we have a unit test executable and a Booster executable lifecycle task. I'll just do build. And so we build each one of those. Okay. What's that?
Options.txt.
Oh yeah, yeah, yeah. So if we go and look at the linking options for those two executables, of course, it doesn't actually give me the name. So we can see for the Booster executable, we can see that it's linking, or it has nothing that's being linked for it because there's no link part of it. If we go and look at the compile part, we can see that the include path includes the Boost headers. If we go and look at the linking options for the unit tester executable options, you can see we're linking in the libcunit.a. And if we look at the compile options for unit tester, we can also see the CUnit headers are being included as well. Is that good? Any questions? So yeah, you see for pre-built libraries, you use them the same way as you would if it was coming from another project. You have a name that you look it up by. You have the linkage. When you define the pre-built libraries, there's only one type, right? You just give it a name and then configure some properties on it. On your jump drive, was there all the solutions for this as well?
Yes.
Okay.
Solutions are there.
Yeah, so there should be a solution directory in the root of each of the exercises, and it'll have a solutions, or version of the solutions. It may not be the exact same thing that we talk about here, but it'll be functionally equivalent. Okay, so we will continue on. All right, so next thing we're going to talk about is native testing. So since 1 dot something, we've had built-in support for CUnit. CUnit only works for C executables or C sources. In the next release 2.5, we're going to be including Google Test support. Right now, I think Google Test support is tied to just C++. And it's kind of rudimentary. It will produce some output. It'll tell you when things fail, but there some rough edges still. Right now, it's also you have to define pre-built libraries for the CUnit and Google Test libraries and headers, and link them against your executables. So we'll see an example of that. So here is a CUnit example. So we apply the plugin C. we apply the plugin CUnit. CUnit adds the test suite support for the native land, and then we have something that's cut here just so it would fit on a slide, but you'd have to do something like we just did in the last exercise and configure where to find the CUnit headers, where to find the library for it, and then we have our component that we're going to be testing, and we have to configure for that component, we have to configure the binaries and link against the CUnit pre-built library. Okay. So there's a lot of things that we want to add to this. We want to basically get it on par with the kind of like JUnit reports that you'll get with pass fails, and we want to tie this into stuff we saw during the keynote today of the feedback for tests running from Eclipse. Like we want that same kind of thing built in for C and C++ or any native stuff. There's also ergonomics in terms of how, right now, since there's no dependency management now, so you have to manually add CUnit and Google Tests. We want to make that a little bit easier. So it's kind of crude right now. Some more other languages that we support. So like Gary mentioned, you can do C++ and C, and Objective-C++ and Objective-C. You do assembler, and we will use the correct kind of tool chain for the platform. So GCC, we're actually calling out the GCC and just saying, hey, here's some assembler to compile. You can also do Windows resources, which uses the Windows resources compiler, like RC or whatever it's called. So we use that as well. Here's some examples we're going to have of different languages that you can add. It all kind of looks the same, right? You apply some language plugin, you define your component, you can define some source sets in it if you'd like. There are a lot of defaults that come with it for where to find headers, where to find the sources, all that. Here's assembly. Assembly looks similar. Assembly doesn't have exported headers. It just has a source directory. If you'd like to add additional compiler or assembler arguments, looks very similar to what we've seen before with CPP. Each of the different languages basically adds a tool that you can configure. So here, if you've applied C and assembler, you'll get the C compiler and an assembler kind of object that you can configure. You can add args or whatever you need. Okay, Windows resources looks similar, the same. This only works on Windows, obviously, but okay. So the big section. So binary variants. So binary variants are basically you take what components do we have, what different variant dimensions do we have, build type, platform, flavor, and then we kind of multiply those out. Right, and that's how many different variations you'll get for your build. How many different builds that we need to, or different binaries we need to produce. We do some shortcutting things. So if a variant dimension only has one thing, then we kind of cut it from referring to it. So if you only have one flavor, then flavor doesn't get propagated out into all the names of things that are tasks and binaries and stuff like that. But if you were to add another one, then you would suddenly get twice as many binaries. So build type. Build type is probably one of the more common ones. You're going to have a debug and release version of your binaries. Right now, there's nothing special about what Gradle does with that, but you can define any number of them. You have debug, release, optimize, debug, optimize, like we have here. By default, there's only one. It's called debug. Okay. And if you want to configure things, so this is saying, okay, for all components that are going to be produced, all binaries for all components that are going to be produced, do this little configuration block. And in that configuration block, we say, if the build type for the binary that we're building is debug, then we're going to do some special things. We're going to set some flags. Otherwise, we're going to, it's going to be the non-debug case, right? We're going to define something else. And the idea is in the future that Gradle would understand build types a little bit better. So a debug build type for native components would mean, and GCC means use these debug arguments, kind of thing. All right, so we're going to jump into that. Okay. All right, so for this, we're going to be adding build types to this project, and then we're going to configure the binaries produced by this project so that it does different things depending on the build type. So we'll do another 15 minutes. If you have any questions, please don't feel bashful. You can even ask Gary to answer your question if you would prefer that. When are we supposed to stop? 5 o'clock? Okay. I don't think I said it, but I mean, things that are related to the model all need to be inside of a model block. So if you're defining new build types, the build types have to be inside the model block, or you get weird, like, I don't know what a build type is outside of it. So are all these labs from DAS originally? Yeah. I kind of see that. Extra cheery. What a fabulous day. Yeah. Sounds a little bit like DAS. I keep thinking it's cherry, and like I keep typing cherry. I might just change it. So it says cherry. And it's not specific. I mean, so you can configure the binaries here for what to do for the different build types. You could do that inside a particular component, or you could do it at the top level for all components. In this case, it doesn't really matter because the define that you add doesn't really matter.
You could do just say is,
Yeah.
I could do the rules inside each component that I'm defining.
Right. So remember when we were talking about the binaries being scoped at a
think a really good sample that we should do. I think needs a little bit work to actually get it to work well. Is a JNI like a JNI mixed Java C++ like, sample.
That'd be a good sample.
Yeah.
It's pretty common these days.
Yeah.
So I've changed the build file in a way that doesn't change output. And I was wondering if it would be built because I've essentially added the example. So I added tool chain in GCC, saved it, and rerun the build. It still says
Came up as
thing
up to
came up
date.
as up to date, and I'm wondering why. We did? What happened here?
Was it compiling with GCC before?
It was compiled with GCC before. I just added a check.
It might be
Why?
So what would you add?
It's not triggering. I mean, it's not seeing the inputs as having changed on compile because of.
Well, he like added like a
Well, yeah,
if
but
we're
it's a
GCC.
definition, right?
Okay.
But it's in. It might be because it's in that binaries,
Mhm.
not all, as opposed to being. Well, no, that's not true. I don't have an explanation for that. I would have expected it to change. Real quick, let's just look at the options that you have in your options text. There's a more build. So
Where?
build/tmp. And then on one of the compile tasks, you did binaries.all or binaries.share. Okay.
So any one?
Yeah. Yeah, it's one of those. Options 8 actually is. And yeah, it's not in there. So it should have triggered the change.
No. What I changed was I simply added toolchain in GCC and. But I already,
Oh, yeah.
I already had built.
Yeah,
type.
okay, you had already built it, and so you didn't change this. Okay, so
Right.
remember, it's based off of the inputs of the task, right? So
the inputs. So it rewrote the inputs. It saw that it had
this
to
didn't
change.
this didn't actually change the inputs. All it did is change the logic here, right?
Okay.
So then he came back and he said, all right, are my inputs the same? Yeah, my inputs are the same. I don't need to run, right?
Right. But if you had been not compiling with GCC before, then adding that would have changed the inputs, right?
Yeah.
Yeah.
Or like comment that out, and what you should then see is that,
Or,
yeah, or add another option, whatever, you know.
I don't know.
Yeah, that's what I was saying. Just comment it out, and when you're changing.
Yeah.
And then if you run it, you should see that it actually rebuilt some of them,
Right,
right?
it
You know, so
rebuilt
Okay, I guess I'll start going over the answer. So it asks us to add some new build types. So by default, we only have debug, so we'll just add debug and release. So if you specify any build types in your project, then Gradle doesn't add any specifically. So if I had just done, that, we would only have one build type and it'd be called release, I believe. Yeah. So we have two build types, debug and release. It says let's add a rule such that release variants are compiled with the macro extra cheery. So this is where I was saying you could do two different things. You could have something inside the hello library, because I know that macro only affects that component. Or I could go the other way. I could say for all binaries produced by any component, if its build type is release, then we want to define this extra macro. So compiler extra cheery. And then it says we want to add a rule such that all debug variants are compiled with the appropriate arguments. So we could just do an else here. And we say CPP compiler args g. All right, so I'm on Clang GCC. So those are my options. If you wanted to be more fancy, you could come in here and say if the tool chain that I'm using is GCC, then do something. There's some samples in the Gradle distribution you could look at and see that. Just to keep it simple, I'll hard code it to my tool chain. All right, so we've done that, and it says let's install run both and look at the output. So we go into there. Okay, so we can see it's built a debug and a release version of the library and also the executable. And if we go under, I'm going to run install. Install debug main executable, release main executable. Okay, and if I look under install here, I have a debug and a release version of my install. And if I run it, main executable debug main and release main, then we can see, okay, with the release version, we get 2 lines of output, the extra cheery output. And if we looked at the source for the library, we'd see when that extra cheery is defined, that's what it's supposed to do. So we know that it must be linked, the release executable is linked with the release library. So that's kind of cool. Okay. Is there any questions about that? Okay. Go to the next set of slides. Okay, so platforms. So platforms are another variant dimension. A platform is related to the type of architecture and operating system that you're building for. I think we're going to eventually extend that into ABIs and runtime and other things like that. But right now it's just architecture and operating system. Gradle uses what platform that we're currently on and what we're trying to build for to go and find tool chains that can actually target that platform. So you can define platforms. It looks very similar to defining build types, only with platforms you can also add extra things. So you can say we're going to define a platform. It's called Win32. It has an architecture of i386, which is the 32-bit architecture, and its operating system is Windows. There's a listing of the different things that we accept here if you look in the DSL guide. But Gradle already defines a set of default platforms, so most of the time you don't necessarily need to do that if you're just building for the simple case, but this lets you define your own your own names for things. Just like build types, you can configure binaries to have different arguments or different macros or whatever for the different platforms. So here say, okay, for all my binaries, if its target platform is this Win32 platform, then we're going to do something special. You can, from the toolchain side, here we're defining a toolchain called GCC of type GCC, and we say when we're targeting I386, then we have this special little hook basically, and it's a kind of like a last resort. Like if Gradle doesn't produce the correct arguments, or you need to add special arguments, you can kind of hook in here, and this gives you a chance to kind of massage the arguments before they get sent to GCC for a particular platform. Most of the time, you'll just be doing it the other way, though. You'll be saying, for this platform, these are my arguments. This lets you do crazy things like renaming, removing arguments, or reordering them or something.
Where can I find the list of platforms?
It's like platform, native platform. Let me look real quick. So in the DSL, platform.
Chapter 54.
Chapter 54.
The user guide, and it's 54.14.2.
I thought it was like listed up here somewhere too, but where's the?
Chapter is building native.
Am I crazy, or was there used to be a search box right here?
Chapter 54 in
We've optimized it, and you no longer need a search box.
It's section 54.14. And it's just scrolling down 54.14.2.
Okay, my wireless isn't working now.
There should be a link in this paragraph.
You can go to the Java doc.
Okay, okay.
Yeah, that's fine. Yes.
So if you go
Yeah.
to the architecture,
Yeah. Okay. Thank you.
Okay. Okay. So the other thing you can do is you can also mess around with the path to the executable for certain tools. So you can say when we're targeting ARM, we're going to set the compiler and linker executables to something completely different. Do stuff like that. All right, so flavors. Oh, thank you. That's why it wasn't working. So flavors. Flavors are another variant dimension. They don't have any kind of special meaning to Gradle. They're just a way for you to increase the number of binaries that you're producing for your components, and add special, like, if we're doing this, then we're going to add these extra arguments, we're going to add these extra defines, or whatever it is. Like the common example we always give is a free version versus a paid version of your application. But you can do it. You can think of all sorts of different ways that you could use that. By default, there's a single flavor called default. We don't do anything special with flavors at all. All right, so if you think about, I've got my components. I've got a couple different build types. I got 6 different platforms. I've got 3 different flavors. Those are all multiplied out. You kind of get like this explosion of variants of different things that you can build. And if you go and look at the task list, it'll just be all these different variations on the same executable or component that you're building. So some of those aren't going to be buildable on your current machine. Some of those don't make sense. Like we'll never want to build that combination. It also has some implications with configuration time and just kind of developer convenience, having these really ugly names. So there's things that we can do to kind of like get that under control. So we'll talk about that in a minute. So a lot of our pieces in the model are these buildable model elements. They're basically things that have tasks associated with them that if you were to depend on that task, you would then know when the whatever it is has been created. What was it? Oh yeah. So like a native binary spec is a buildable model element. It's an executable binary that's produced by the linker task, which the linker task then depends on the output from the compile task, and the compile task all the way up. So these are different types of binaries that you can produce, different type of buildable model elements. Our source sets are also buildable model elements. So if you have like a generated source directory, you can actually say, okay, I have this source directory, it's generated by this task, and then if I depend on that source set, I will automatically wait for that other generation task to run first. Okay, so like I said, you can turn off some of these binaries. So let's say we're saying, okay, for all the binaries that we're building, if some special condition is met based on that binary, it's a debug free, whatever binary, we know we'll never build that combination, and we can set its buildable flag to false, and that means we won't try to build it. We can also create convenience tasks. So here's some examples of different convenience tasks that we can create. So we can say we want to have a task that will build all the release executables. So we're saying, okay, select the binaries that are executable and they are of build type release, and have a task that depends on that. We can also that depends on the compile and linking steps of the executable. We can also say we only want to do the compile step. We want to be able to compile all of our library sources from one task. So we can say, okay, we have a compile all library CPP, and we're selecting all the library binaries, and we're grabbing off the only the compile part of that task, or of that binary. And same thing at the bottom, where we're saying we only want to depend on the shared libraries. So we want to have one way to build everything that is a buildable shared library. Okay? And this works because basically the collection that comes out of this matching is a collection of buildable model elements. And so then Gradle takes those buildable model elements and grabs all the tasks out of them and sets up the dependency graph based on that. Okay? So that's what the next lab's going to be about. I'll switch to it. So we're in the last one. And it's basically, we have a example here of kind of the explosion. We have two build types. We have two flavors. We have three platforms. And when you look at this, you'll have lots and lots of tasks. And we want to make some convenience tasks for our developers, so they can build subsets of all the things they can actually build. So we'll do another 10 minutes or so. What time is it? 4:30. Yeah. Yes, ma'am.
Those variants apply to pre-built libraries too?
Yes, they do. Yeah. So you could have like if you had like a debug version and a release version of your pre-built libraries, you could also, inside that binaries block, inside the pre-built library, you could say if the pre-built library is for build type, debug, then select this other file for it. So yeah. Sir.
There's a width type. Is there a width platform?
There is a matching, and matching you can kind of do whatever you want inside of it.
So the buildable property, when you say it buildable, where does buildable come for? Yeah,
Right. So this down here. So basically, what's being passed into this closure is the thing that's been matched on back here. So it's going to be a type shared library binary. And if you go and look, well, I don't have internet access working, but
Okay, so
it is a binary of some kind. So I think it's either binary or maybe the parent class above that has a buildable flag.
why? Oh, say if I want to use matching, I have to say with type. I cannot
No,
say
you can do everything that's inside of binaries is a binary, and it has a buildable flag in it.
What you're really doing there is chaining two different
Yeah.
rules together.
Yeah.
Right? So binaries.with type, you could create a rule like that. You could say binaries.matching and create a rule like that.
Yep.
Or you can combine them together and say binaries.with type and matching. Right? So you're just
Yeah. So
adding a whole bunch of conditions onto.
yeah, there's,
So I know I cannot build the x86 on this machine. I just tried and it failed. So that's how I discovered I couldn't build it. So now I want to extrude it.
right.
So it's binaries matching it dot. Okay, so it's not buildable. It has to be properly. Target platform.
Yeah. So you can say
Target platform.
it target platform. Yeah, equals something. You know. You can do it that way. I mean, so that's if you had like a really short, like that's why the it buildable was that way. If you have a really short expression that you're selecting on, then the matching makes sense. I think if you start getting where it's like a complicated, like compound type thing, then I usually just fall back to what all these are doing, where you just say binaries all, and then you can just say if this, then set to this way, or if that, set the other way. Depending on what you want, I guess.
Yeah, I just want to learn how to find it in the user guide.
Yeah, so I think what you have to do is the DSL guide hides the like kind of like hierarchy of types a lot, which is very annoying. But so what you end up having to do is go to JavaDoc. So if you go to, where's the example? If you were to go to the shared library binary DSL guide, and then click on the JavaDoc, and then you can see the hierarchy, and you can see all the different things that are available. So if you go to, so if you look for shared library binary.
I want to exclude anything that's got x86, whether it's shared or
Yeah. Oh, so you can just do the next thing up from that would be a native binary. So if you click on the native binary there, or native binary spec, I think one or both of those are going to be good. Okay.
target platform.
Yeah. Yeah, the way we generate the DSL documentation right now hides parent stuff, and so it won't be listed necessarily. You guys want a few more minutes? Play with it? Okay. I know. It's like you're planning it. You just need a little elephant on it now.
Yeah, exactly. Gradle font.
Gradle font. Yeah. Sure. So the target platform is going to be like a platform object. So it's not going to be a string. So it's going to be like you did with the build types, where you would say build types dot something. So here you would say platforms dot, and then whatever the x86 platform name was. So if you scroll up a little bit, I don't remember what it was called. Yeah, x86. So you would just say target platform equals platforms dot x86. Yep. Yep. Is this right? That's Gradle 15. Okay, good. Otherwise, I have to put my room number in. I don't really want any visitors. Let's see if this documentation link still works. Good. Okay, would you guys like me to start talking about the answer? Sure. Okay, so it asks us how many binaries do you think we're going to produce from this build script? We have 2 build types, 2 flavors, and 3 platforms. 12, yes, okay, good. Hopefully that will be the number that we see now. So if we go and run Gradle in this build, we'll see a bunch of helper tasks, right? So 12 is almost right, but we had some libraries. So there are 2 libraries for every library component. We have 2 linkages, shared and static, right? Yeah, so it's 24 or something like that. I don't remember what the number is. So we look at this and we say, hey, Mr. Developer, please pick your poison of what to run. So it says, what happens if we were to pick a binary here that won't build? So I'll just pick on Spark, because hopefully nobody here has a Spark laptop, if such a thing exists.
Oh, no.
Yeah, so if I run Gradle and the Spark thing, it blows up and it says you're trying to build for the Spark platform. These are all the different tool chains I'm going to look for, and none of them know how to build for Spark. Okay, so it says let's create some helper tasks that will let us build all the buildable variants, build the debug and static libraries, and also run an install developer image, so run all the install tasks. So we'll start with the build all. So we're going to say, okay, we have task, build all, and it can just depend on any, was it everything? All buildable, yeah. So we say if it's buildable, like that. So any buildable tasks or any buildable binaries, we want to build all of them. If I actually go and try to run that, it'll run a bunch of builds, and we can take my word for it. It's going to build all the right ones. So that's okay. It says let's build all the static libraries with the debug build type. So we can do the same thing there. We can say task build debug static libs, and it's going to depend on binaries with a certain type. The share or static library binary, and we also want it to be buildable. Oh, and we also want it to have build type debug. Right? Build types debug, yeah. So build debug static lib. Right. So we can see we have debug static libraries in there. So that's one way you could have written it. You could have written this, since this is getting kind of long and kind of crazy looking. You could have also done something like binaries with type static library, and then just said all. And you could have done it in here. You could have said if it's buildable and its build type is debug, then it depends on, what was it? Yeah. You done something like that. That should be the same. So it is the binary that we're applying the rule to, and depends on is for the task that we're inside. Okay. So I'll take that back out. So the last one, it says let's make a install developer image task, and what it's going to do is it's going to get all the buildable executable binaries that are debug and are for the x64 platform. So this one's a little bit more tricky because all the ones we've done so far have been just building, like building and linking. We haven't wanted just like one particular type of the task that that's related to a binary. So we're going to say, okay, task, install developer image, and we're going to say, okay, for all of the native executable, and we'll just do it the other way. If it's buildable and its build type is debug, then we want to depend on the install executable task. I believe that's right. Is that all it wanted us to do? Oh, and platform. Okay. And the platform, and the target platform, I'm not sure why that one's different, is platforms.x64. Okay. Install developer image. And so we can see it's gone out and it's found any of the binaries that are debug, are x64, and it's grabbed the install tasks for that binary. Okay, so the tasks here is on the binary, and it's a collection of all the different tasks that are related to that binary. So compile and link and that sort of thing. Okay. And so now it says, let's. What happens if we remove the release and regular flavor of these build type or flavor and build type? Any guesses? So regular and release. If we go look at the tasks again, we'll see that where it used to say debug and cheery and regular and all that in the name of the tasks, now we don't have that because Gradle's taken it and says, oh, okay, you have one build type, you have one flavor, we'll just say that's not a important detail anymore, and we'll remove those from the names. Okay. Any questions about this? Pretty good. Okay. So I think we got a few minutes real quick here. We'll talk about some future stuff we're going to be doing. That's the last exercise we're going to be doing. All right, so things we didn't really cover. We didn't have a lab about precompiled headers. We didn't really do anything about the C unit stuff. The IDL support is like if you have generated sources. We didn't really talk about that. These are all things that you can do or will be able to do very soon in next release. But it's only 3 hours. So in the future, so variant aware dependency management is a really big thing. Like Adam said, next 6 to 12 months, that's what we're going to be focusing on. The idea of public and private headers. You can kind of get that now with having headers in your source directory and having your exported headers or your public headers in an exported headers directory. Support for system library. So this is like platforms and or was it platforms in Mac OS? What do they call it? Frameworks, like frameworks and stuff like that. Making that easier, because right now the only way of doing that is to drop down into the compiler linker args and say add these extra arguments, and Gradle doesn't really understand what those are yet. We would like to have built-in understanding of different types of build types, so it just sort of does the right thing based on your build type. And we just really want to try to make Gradle a great native build tool, not just for Java and the Java land, but just for everything. All right, so thank you. I'll stick around and answer any questions you have. If you want to talk about some more publishing stuff, whatever you want to talk about, we're here. So thank you for coming. It's been a lot of fun.